Hey class, this is Gigi from Kauai Community College. This is a question of limit at infinity as it relates to the horizontal asymptote. Okay, so the horizontal asymptote by definition is the limit as x goes to infinity or negative infinity, meaning what happened to the function when x is way out there to the left or to the right. So we really have to look at the limit as x goes to infinity and the limit as x goes to negative infinity. Now, if it's just one answer, then you have one horizontal asymptote. And if these become two different answers, then you have two horizontal asymptotes. Okay, so one thing to consider for this function, because of the square root of 36x to the 6, we know that we have to divide by the same thing here. And usually we just divide by the highest exponent that we see there. But because of that square root there, we would have to say, well, I'm going to have to divide by square root of x to the 6 and square root of x to the 6. But the question here is, what is square root of x to the 6? Square root of something by definition have to be a positive number, so it must be absolute value of x to the third. Now the absolute value of x to the third, when written without the absolute value, it will have to depend on the value of x. If x is 0 or higher, then the absolute value of a positive number is itself. However, if the x is a negative number, then the absolute value of x has to be its opposite. The opposite of a negative number is a positive number. That's what this means. This actually is a positive number, not negative. It's just written with the opposite of a negative number because x to the third is a negative number. And x to the third is a negative number is because x is negative. Okay, so when does this come to play? This come into play when we are approaching the negative infinity. Okay, but since it's positive, it's just normal. It's just like x to the third. So limit as x goes to infinity. And so since we are approaching infinity, x is a positive number. So then the square root of x to the 6 is just x to the third. So then you'll have 2 plus 6 divided by x to the third. And then here you'll have 3 plus square root of 36 plus 2 divided by x to the 6. Okay, so nothing funny going on here. And then when x goes to infinity, this is 0, and this goes to 0. So all you have is 2 on the numerator. 3 plus square root of 36. Square root of 36 is 6. So you have 2 over 9. Okay, so nothing fancy there. However, we really have to be careful when we are taking the limit as x goes to negative infinity. When x is going to negative infinity, we are talking about a negative number. So that square root of x to the 6 is the absolute value of x, which is the opposite of x to the third to denote a positive value. So when we are making that division, we are saying this is negative. So 2x to the third divided by negative x to the third, this is going to be negative 2 minus 6 over x to the third. And then this is going to be negative 3 because x to the third divided by negative x to the third is negative 3 plus square root of 36 is still the same because it's inside, plus 2 divided by x to the 6. So here, this will go to 0, this will go to 0, right? As x goes to negative infinity. So you will have negative 2 over negative 3 plus square root of 36. And square root of 36 is 6 minus 3 is 3. So you will have negative 2/3. So you have two different horizontal asymptotes. The line y equals 2 over 9 and the line y equals negative 2 over 3 are our horizontal asymptotes. Now, if you're sitting there thinking, oh, that's weird, two horizontal asymptotes, how does that look like? Well, throw it into decimals. You will see that this one right here is y equals 2 over 9. And this one right here is y equals, I mean, not that part, but this horizontal asymptote right here is 2/9. And then this horizontal asymptote right here is y equals negative 2/3. That's what we have found. Two different horizontal asymptotes, because that's how the end behaviors of the function look like, to the left and to the right.